Any loyal fans of the Big Bang Theory's Sheldon Cooper are probably familiar with the name Marie Curie. But do you know who Marie Curie is and the impact that she left on the physics and chemistry world? Marie Curie was a Polish physicist and chemist, a two-time Nobel Prize winner, and a pioneer of the field of radiation in the medical field. Her story, however, partially begins with Pierre Curie, who would eventually become her husband, and in 1882 he earned a position as the head of the lab at the Paris School of Physics and Chemistry, a place in which Marie Curie would later end up at and eventually become the first female professor at the school. Nearly 10 years later, in 1891, Marie Curie launched her own career and furthered her education in physics and chemistry. In fact, one of her major contributions to the field of chemistry was pioneering the term radioactivity. This had previously been studied by another chemist who had been working on radioactivity, but Marie Curie put the name to the process. Radioactivity occurs over time, and it is the measurement of how many atoms are left in an element after a set amount of time. For more information, check out this timeline and specifically this node in the physics category to learn more about what radioactivity is and explore some examples. But Pierre and Marie Curie's careers really took off with the element hypothesis in 1898. The hypothesis stated that they believed there was another element aside from the already known radioactive uranium, which essentially launched and gave their research a platform to build upon. They believed that they could isolate these new elements by taking pitchblende, which is a uranite made primarily of uranium. However, pitchblende is 10 times more active than uranium, and the Curies found that there was not enough uranium atoms to account for the high levels of radioactivity. Thus, they concluded that there must have been another element, and this is when they discovered polonium. Polonium was named after Marie's homeland, Poland. However, there were ample amounts of controversy over whether polonium was actually a new element or if it was just a variation of an already known element, especially because the Curies had not been able to isolate polonium, and thus they could not find the atomic weight. But just a few months later, in December of 1898, the Curies found evidence of another element that they later named radium. Radium was very similar to barium, which caused the scientific community to also consider its validity. Thus, they used fractional crystallization, which involves boiling substances and then allowing them to cool and crystallize until they find the abundant components. They found that their new compound was radium chloride. This experiment was later evaluated by spectroscopic named Eugene Demacre. It took several more years before Marie Curie and her assistant were able to finally isolate radium into radium chloride. But they were able to create 0.1 of a gram of pure radium chloride, which eventually led to Marie Curie earning her doctorate for her pure isolation. It also led to Marie and Pierre Curie being awarded Nobel Prizes in physics. This was the Curie's first Nobel Prize, and it also made Marie Curie the first woman to ever win a Nobel Prize. They were recognized for the extraordinary services they have rendered by their joint research on radiation phenomena, as cited by the Nobel Prize Association. However, there were still questions in the air about the validity of polonium, and years after its discovery, Marie Curie and her assistant were once again able to isolate her new element. And while it was still a small amount of only 0.1 of a milligram that came from tons of uranium samples she had obtained, it proved that polonium was in fact its own element and separate from radium and barium. For this contribution to the scientific community, Marie Curie received her second Nobel Prize. She became the first person in 1911 to win 2 Nobel Prizes and the only person to date to win a Nobel Prize in physics and in chemistry. But Marie Curie was not stopping at just winning Nobel Prizes. In fact, she was looking for her research to be applied on a wider scale. And during World War I, she traveled and observed the medics in the field. She found that they were limited to primarily one X-ray system for hundreds of injured soldiers, and she began to work on a portable X-ray system that used her radiation to create X-ray images outside of the body. This was very helpful during a war because they weren't able to travel as much, and also this was portable so that they could help more soldiers quicker. This also began to expand her research in her Radium Institute in Paris. You can find out more about the Radium Institute at the University of Paris in this timeline. She also began to have doctors begin research on using radiation as a form of cancer treatment, which is still a treatment used today to battle cancer. However, since she was a pioneer in her field, Marie Curie did not know the danger that excess exposure to radiation could have. And after years of working with radioactive materials, Marie Curie sadly died from leukemia due to exposure in 1934. However, her legacy has lived on in her daughter, Irene Curie, when her and her husband won a Nobel Prize for being able to artificially produce radioactivity. This previously had not been proven. Even outside of her reach of her daughter's field, Marie Curie has left a lasting impact on the scientific community and how we understand medicine today. She also set an example and became a role model for women around the world in STEM. Please explore this timeline to learn more. Thank you.
If you enjoyed this video, don't forget to follow us for more engaging content. Every Friday for the next few weeks, we'll be sharing fascinating stories about historical events that took place on Fridays. Stay tuned for more fun and intriguing history brought to life with Clevis. Ready to create your own timeline? Start your Clevis journey today at clevis.com and dive into history like never before.